Hey, and welcome back to another video. In this video, we're going to look at walls. So basically, this is going to be a series that is looking at everything walls because, I mean, let's be honest, your Revit model has a ton of them, and you got to know how to use them. You know, every little thing about walls, and we're going to cover it. Believe me, it might take some time. It might take some time in this video and then in the series. So constantly look back at this series. You're going to need it. I'm going to need it. My gosh, I end up making videos and having to go look at the video to see how the heck I did something. So before we get into it, if you happen to learn something, which let's be honest, that's why you're here, please demolish that like button. And we're going to learn about walls. So I'm in a basic architecture template in Revit 2022, and I've drawn a wall. I literally have selected the wall option in the architecture wall tool right there, and I've drawn a wall. That is it. And so you can see here that is generic 8-inch wall. And so honestly, this is going to be the first step, of many wall videos. And so what I wanted to cover in this one is nothing too specific, but everything to do with instance properties. So like when you click on a wall, instance properties are over here to the left, the properties there, of course. And so what do they actually do? And let's explore that. So first thing here, we could see whenever I select it, I actually then get my instance properties. That's the first thing. I have instance properties of the view unless I click on the wall. I will actually receive the instance properties of that particular object that I've selected, which in this case is the wall. So with the wall selected, you can see I have one wall selected, and then we can start looking at all these different options. There's a lot, but they're not overly complicated, and it's good to know what they are because they're going to be consistent for everything walls. Of course they are, but obviously they will change for other types of, Revit elements. That's just something to be aware of. But before we get into anything specific as far as a type property of a wall or anything that we could do with a wall in the type, I want to make sure we know what the instance properties are, how they work, how to manipulate those, and what you can do. So here we go. The first thing here is we've got the location line, and that has everything to do with where you're placing the wall. So you can see it's currently set to wall center line. Now if I come up here to wall and I go to place a wall but not having placed it yet, I have very similar looking settings up here at the top green bar. I can modify the height and basically set the top to be a certain level. By default, it's set to unconnected, and we'll get to that in a second. But here we can see location line. And so I can determine where I want my location line to be before I even draw the wall. And so first, what is location line? Well, that is where you're drawing the wall, specifically where in the wall are you going to draw the wall, and where is the wall going to be based on where you're drawing it. There's 100 ways I could say it, but by default it's the center line. So basically it's the center of the wall. So where I draw the line or where I draw the wall is going to be centered. And so if we look at our other options here, there's quite a few. So we have core center line, and if we're using this particular wall type, I can draw this, and it's going to look the exact same, of course, but what we have here is now this location, this dot or this drag in this end point for the wall is placed not necessarily at the center line of the wall, but at the core center line. And I'm only going to open the type properties to show you this, but I'm going to go to the type properties and then the structure, edit the structure, and I can see here is core boundary. So because this is a generic wall, the core itself is 8 inches. So that's all that there is. So there's only a core. And so I'm going to get out of this now so it doesn't confuse everyone. And so with that, we can see that these endpoints are in the exact same place. And that's because, again, there's only a core, which means that the wall center line and the core center line would be considered the same place. Okay, cool. We've looked at that. So let's go ahead and draw another one. Why not? And so in this case, I'm going to change this from core center line to finish face exterior. And so this is nice. I end up doing this a lot because maybe I know exactly where the exterior of my building is, and I want to basically build backwards from that. Well, okay, I can come over here and I can draw that. Well, look at this. So you could see that I'm drawing from the exterior, or really one side of the wall or the other. I can press spacebar while I do this, and the wall will flip. And so in this case, it ends up being that if you want to use this, if you know where the exterior of the wall is. Okay, great. Well, I happen to know where it is. And so it's right there. And because it's there, here we go. Look, I can see this here. I can see that my end wall is, or my end point of the wall is at the edge, basically one side of the wall. This is going to make more sense when we use a different wall other than generic, and I will get to that. But look at this. We could see that the end point is at the edge, which correlates and makes perfect sense for the finished face exterior. So I can basically drag this along the exterior. So if I were going to continue this, let's say that I were going to continue this wall and I were going to use this point and drag it up here, well, I can just flip this. And so maybe the exterior of my building is right there, and I know exactly where it is and I can follow it. Well, that's kind of the point here. And so that's nice. And so we're going to keep going here. Let's place another wall. I'll change that location line to finish face exterior. So the thing here is that maybe this is where, like, okay, I've drawn the interior of my building, but I don't know what the wall makeup's going to be at all. I just know the interior boundary of my building, so I can start with that and then just build out from there. I tend to do the opposite, but it doesn't necessarily matter. It's all the same. And you'll see it's all the same immediately, because when I draw this with finish face exterior or interior, I get the same effect. I can flip this, and so really it ends up being the exact same to a degree. It ends up being the exact same in that you have to know where the interior versus the exterior is of your building, which obviously but also the interior versus the exterior side of the wall matters. And so if you're working with, let's say, symmetrical walls, which these are all symmetrical because there's only one unit, one piece to the wall, then I'm always symmetrical. But if once you've built a wall that has a bunch of different things built into the structure, that will matter, and you'll obviously see that. So when I go and place this, it doesn't matter where I place it. It's all the same because I can then just flip it. It's really based on that line. Is the line you're using in this case the interior or the exterior? It just matters. A lot of times what I end up doing is, again, using that exterior, but maybe I know the interior for a particular room as opposed to the exterior. Maybe a certain area within the building matters and another one doesn't, so then I'll build the wall out from there. It's really preference, but knowing how to use it. So then finally, let's click on wall, and now I can use core face exterior and interior. So that's the exact same thing as finish face exterior and interior, except again, it's looking at that core. And so maybe this is probably a bad example for a wall, but when I draw this, you can see it's basically drawing the exact same way as finish face exterior or interior, except this is the core. And remember, that's because the core in this particular wall is it's everything. It's only a core. And so what I'm going to do at this point is change some of these walls to a different wall type, just so we can get an idea of what's going on. And let's go ahead and do this exterior brick. And so okay, we have a lot going on here. Well, nothing changed, but that is because our view actually is set to coarse, and we can't see the details of a wall if the detail of our view is set to coarse. I like using fine or medium. 99% of the time, it's not going to matter, but you can get away with what you want to see at medium. But for this case, I'm going to put it at fine just so we can see absolutely everything. Okay, so let's space these out a little bit more. And we can see we have 4 walls that look the exact same. But again, I'm going to click on the walls, and we can see based on where their location is what we're looking at. So here is the core center line. Well, immediately the core is the stud. And so in this case, my stud is here at the left, and you can see where I'm dragging. The core center line is the center of the core, in this case the stud, which is really cool, really helpful. Moving on to the next one, I can see finish face exterior. Well, obviously this brick is the exterior, so I can move about that boundary, which is great. And if I click on this one, which is finish face interior, I can see there's my interior. It's along that stud line on the interior side. And then finally, clicking on this one here, I could see core face exterior. Well, this is the exterior side of the core. I honestly don't use that a ton. There may be particular reasons why you might need to have studs line up in a certain place, so then you'd use that. Let's draw one more wall, but in this case, I will change this to core face interior, which, because this wall ends in a core and not any sort of finish beyond that, it's going to end up lining up in the same place that we would see for finish face interior, which is going to be along that stud line there. Okay, so we've looked at everything as far as the location line, and they're all different in this case, which is not a huge deal. So then the next is base constraint. By default, I assume you're working with level 1, whatever it is. It's going to work with the default. In this case, it is level 1, so they're all going to be drawn at level 1. Basically, the bottom of the wall is at level 1, that's generally what you want. And I wouldn't recommend changing that unless you absolutely have to. And then we're going to come back to the base constraint here in a second. When we get to base offset, we need to go to 3D at this point. So let's go to 3D. You can see all of our walls here. So I'm going to click this one there, and we can see that I'm going to click my base offset. Maybe we'll set that to 3 feet. So this is going to now move 3 feet. Literally, the whole wall is going to move up 3 feet. And now, okay, that's fine. Maybe you'd want to do that, maybe not. I don't know. But that's there, and just kind of know that you can do that. Again, we're going to get back to all these constraints because now we have a top constraint. So the default, if you're just going to go click on wall in architecture and then draw a wall, the default's going to be level 1 or whatever level, and then have an unconnected height of generally 20 feet. And so that just is what it is. What I see a lot of people doing, and what I see myself doing a lot, I'm definitely someone who does this, is I don't set a top constraint. I just end up changing the height because maybe I know, the next level is 20 feet up. So then I'll just know that, I put an offset of 3 feet. I can put this to 17 feet. And now I have everything lined up. It looks great. Well, this is not proper modeling, and proper modeling, while it looks proper and it looks fine and it looks like it should, maybe, this is not proper modeling. And by proper modeling, I mean this wall is, you could say that it's floating in space because it is. It's 3 feet above the ground, and whether you have a floor there or not, it would consider to be floating because we haven't tied that down to a constraint. In this case, the base constraint, you're going to have a base constraint because you drew the wall. But in this case, it's level 1, and I've just drawn an offset. I don't care as much about the offset in this case because I have a base constraint of a level set. But what I am not liking so much is that I have an unconnected height of 17 feet. And that just means that no matter what I do, let's say level 2 changes, this wall, the top of the wall, is not going to go anywhere. It's going to stay at 17 feet above, this level 1 with a 3 foot offset. Like, that's where it's going to be. And so the way I like the really proper modeling looks like this. So if I want this to be 17 feet, in other words, 20 feet above level 1, but have a 3 foot offset, this is how I would do it. I'd come in here to up to level 2. So basically it's like, where do you want this wall to stop? I want this to stop at level 2. And so whenever I see it stopping at level 2, I realize, well, okay, I can see my unconnected height, which is nice. This is the height of the wall itself, which is only 7 feet because the distance between level 1 and 2 is 10 feet. You can see that there. And as I change this, maybe I put this at 5, the top of the wall doesn't move because it's at level 2, but my unconnected height does. And so let's put this back to 3. And what am I left with? Well, basically, how do I get it up to 10 feet higher? How do I do that? Well, I can add a top offset. Ideally, what we would do is have a level 3, basically level 3, 10 feet above level 2, and this would just stop at level 3. But let's say this is the roof and you're drawing a parapet or something like that. Well, you would want this wall to stop at the top level. In this case, it is only level 2, but I would want to add a top offset of 10. And so that gives me exactly what I want again. So what we're looking at here is my unconnected height is 17 feet, which is what it was before, but I have a top constraint of set to level 2, and then my offset is 10. So you can start doing all the math, and we get to the wall itself being 17 feet. It in reality, it's constrained between level 1 and then 10 feet above level 2, so 20 feet, whatever. None of that matters, but we get what we want. And so why is this proper modeling versus what we had before? Well, that's because I have now put a not only base constraint, which I have to have, but a top constraint, because that means that when I move levels, let's say for some weird reason, and I hope this doesn't happen, especially later in a project, that level 2 literally moves up. And so for the sake of this video, let's do that. I'm going to come in here to level 2, and I'm going to put this at 15 feet. And let's go back to 3D and see what happens. Well, whoa, what happened? Well, none of these walls move because they have no top constraint. They're all unconnected at 20 feet, so they don't care about what they're tied to above because they're not tied to anything. But look what happened to this wall. It still has the top constraint of level 2, and I still have my top offset of 10 because I set that myself, but the unconnected height is 5 feet higher because level 2 is 5 feet higher. And so you can see why this is immediately more important to do and really proper modeling, because now this wall is responding to changes I've made in the model that don't just involve this wall. It's literally tied to the rest of the model, which is why we have levels and tie things to levels and all that. It's so important to do this. I will say I don't do this for every wall just because I don't, it is what it is. Because a lot of times I'm working with interior walls that are only on level 1 or something, let's say like that. So what are we going to do about that? Well, the exact same works. Well, if I come in here and we'll just put this as 0 because this is the default. So I have 15-foot wall and maybe my ceiling's at 10 feet. Well, I can leave my top constraint at level 2, but then bring my top offset down by 5 feet. And then I've achieved the exact same thing. I have an interior wall that's tied to level 2, and then the offset is down 5 feet. Like it's beautiful. It's perfect. It's all tied together. So that is something I would highly encourage you do and get used to doing, because it's going to greatly improve your model as far as like working with it as things change, especially those datums when they change. It's just really important to know what things are tied to, and then knowing that if you have to move them, you don't have to touch every wall and change them. And I've had to do it, and it's a mess. All right, let's move on from offset. We've got this top is attached. Well, what are we looking at here? We've also have base is attached, and what is all of this? Well, let's go ahead and draw a floor in here. It doesn't need to be any particularly fancy floor, but I'm also going to copy this floor, and I'm going to go to modify and paste this, align the selected level, in this case 2, so I have basically 2 levels here. And so look at this. So at this point I'm going to click this wall because this is kind of the one we're using, and I can see that top is attached is not only grayed out, base is attached is grayed out. None of this is really active. And so why is that? Well, when I click on this wall, I can see that I have attached top, base, and I have detached and all that. So let's go ahead and attach something. So whenever I click attach, I can see I've got a top and a base. So let's click on top, and that's the default. But now I can basically choose where this wall will be attached to. And so I can click level 2, and what happens? What happens here? Well, not only is it attached to level 2, in other words, whenever I move this, I'm going to jump in right here because it's not attached to level 2. It's attached to this floor. And this floor happens to be at level 2. So let's go ahead and change where the floor is. So -2. Well, we can see the wall moves perfectly with it. So this is great. I'm not going to say that you should do this for every wall because I want to show you a few things here. The main thing is that none of these offsets changed whatsoever, which is interesting. If I put this back, maybe if I put this at 2 feet, the wall moves with it, which is good or bad. It's hard to tell. But you'll notice here the unconnected height is still 10 feet, which is actually wrong in this case because the distance between, we can look at the distance here, the distance 0 and 17, or in this case 16, it's definitely not 10 feet. So the problem with attaching is that visually it's attached. Visually, it goes with that floor. It moves with it. This works with roofs and floors and I believe ceiling as well. But the information with this wall is not updated, which is kind of confusing. It's unfortunate. All of that can be true at the same time, and it is. But why would we want to attach something? Well, we'd want to attach something, and this is more of an opinion of an answer than anything. If we know that this floor is going to move a lot, and we don't want to worry about this wall, having to change this wall, update the wall location, offsets, or anything all the time. Well, okay, that's the best thing I can tell you. I end up using it a lot for roofs. If I need a wall to actually angle correctly, then that's why you'd want to use it for visual purposes. But also, if this floor, like this one is, it's not actually at level 2, I would have to put in a manual offset to get it there. Then attaching it's easy. Now, while the constraints, top and base constraint, don't actually change, whenever this is ultimately attached, I do have an area and all this information down here. I'm kind of jumping around a second, but the length and the area, of course, the length doesn't change. The volume and area do change, which is cool. So I have my 272 square feet right now, and if I click on this wall and then end up detaching it, we can see that, the area is 170. So the nice thing about this is that it will have an accurate area, which is good. It's literally what you see. What you see is what you get, except when it comes to these base constraints and top constraints, things like that. So interesting. Just these are things to know. That I'm not necessarily telling you to attach every wall to every floor. Please don't do that, because every time you move a floor, things will blow up and change, and things may not end up where they need to be. And so here's another issue. I've seen this happen a lot, where I end up having this wall. Maybe it's supposed to be, way the heck down here. Maybe it's just 5 feet tall or something like this. So I've set it up correctly, but maybe it was actually attached to level 2, and so I get this, and I just see this wall. I'm like, what the heck's wrong with this wall? It should be 5 feet off the ground, and I don't know what to do. If I don't think to detach it, it's literally like, I don't know. I don't know what to do because it's detached now, or it's attached. Now you can see this here, and this is something to be aware of too. You can see top is attached is now checked. Base is attached is not. So we can attach base and then choose this floor here. Nothing happened because technically the wall was already on the floor. It wasn't attached. So I would never attach it to a floor that it's essentially on, especially if that's on a level. But now when I click on the wall, I can see that base is attached is checked, and then top is attached is checked. Cool. Good to know. But also just know that that's really where the wall is. That's where the wall is modeled. And again, you can always see that based on these constraints. Okay, moving down to room bounding. Well, if you've dealt with rooms, if you've made rooms, or if you have had to draw extra boundary lines for rooms, then you know kind of what happens. Well, by default, rooms are created by boundaries, and those boundaries are generally lines that you can draw. But what's also nice is that you don't have to draw all of them, because walls and columns serve as room boundaries, which is great. Doors and things that you cut through them don't impact that at all, which makes sense because it shouldn't. But in this case, this wall is considered to be a room boundary because it is. And so let's come over here, and I'm going to extend this floor out a bit more so it makes sense. And I'm going to take this wall, end up copying this over, and let's just draw a few more instances of it just so I could literally get a box here. And with this box, I can come over to architecture, room, and then dump a room in there. So cool, look at that. I have a room, and the room is bounded by these walls. And so if I choose this wall, for instance, and I uncheck room bounding, suddenly I get this pop-up, and this is room is not properly enclosed. But why not? Well, it's not, because I have this room, which is within these four walls, because these walls are serving as room boundaries. And I basically just said that this wall is not a room boundary anymore. And so now I have three walls, which are a room boundary, and then one that isn't. So it's basically like this wall is not technically there when it comes to this room existing. And you can see that, this room doesn't have a place. It's just kind of floating here. It doesn't matter. And that's because, again, this wall is not serving as room boundary. Now, when I check this back, boom, this whole room's back, and I have this room back, which is great. I very rarely need to change this. I don't need to. If the wall is just like an extra little pony wall in the middle of a room, then you can uncheck it and it won't count. I don't know. I really haven't needed to use it, but it's more of just knowing what it does and when to use it and all of that. So just kind of know that. Maybe for some reason someone unchecked it and you started copying this wall around, and you're like, why can't I make rooms? Well, maybe you copied a wall that someone else had unchecked for room bounding, and none of those walls that you're copying around end up bounding rooms, creating rooms, allowing rooms to exist. So something to be aware of as well. All right, cool. So let's go ahead and click this wall again, and we will see, moving down here, there's structural. Again, this is definitely something that I really don't use all that much, but let's go through it so we know what it does. Structural. Whenever I click this, a ton of things happen. Well, I can enable analytical model, which I would never uncheck. Structural usage, you can change the type, whether it's a bearing wall, a shear wall, or some other structural combined wall. And then we've got all these rebar. As an architect, I don't need this at all. I don't use this at all. So this is very much not for me. It's obviously more for a structural engineer. And if you are a structural engineer, you're probably used to this and know what it is and all that. The only reason I would end up checking structural or dealing with any of this at all is that maybe I want to create a wall schedule, and I want to start filtering walls out, or like understanding which walls are considered to be structural. Maybe you need to determine those yourself. You can make a schedule that would basically sort by structural walls that are checked, because you might want to know and be able to track that and compare that to structure and all this. So that's the only time I've done it, but most of the time I'm not. And so whenever I'm using this at all, I'm only checking structure and then walk away, and I'm done. And so this wall is now considered structural. And whenever I want to filter or sort in a schedule, a wall schedule, then I can use that option. So 99% of the time, don't need it as an architect. So again, we've looked at the length, the area, the volume. It's really great. It responds to the size of the wall. I mean, It's all BIM data, as in building information modeling. It's all built into the wall, which literally if you're looking at the wall or anything like this is the BIM data. This is kind of the stuff we want. Now, there's a lot more we could add to it because there's really more stuff, but that's kind of the built-in data. And you'll notice that anything grayed out is something obviously we can't change, but it ends up being that this information is kind of built into Revit already. Or in this case of structural, I can't access it until I check this box, so that's fine. I ended up skipping this cross section, which is it's one of the newer options that we have with Revit walls, which is kind of interesting. So I'm going to go into 3D here. I don't want this floor. I also don't want this to be 5 feet anymore. So let's put this at 10 feet. That's fine. But you can see my cross section is vertical. Well, what the heck? It's the type of thing where you don't realize what it does until you start changing it. So vertical means you're always going to have a vertical wall. We can see a similar, something similar when we look at a column. When I click at a column here, I can see, well, I have a vertical column and I have a slanted column. Like, ooh, okay. Placement, also look at that too. So whenever I click on this wall, I can see cross section is vertical. Well, we just looked at it at it's vertical. What are some of the other options here? Well, I see slanted. So whenever I click on slanted, I get one more option that I can work with, which is that angle from vertical. I think this was first within Revit 2021, which is great, but it allows us to get a few more options to work with here. I could put this angle from vertical, which means, again, vertical is 0, and I can start changing this angle. So if I put this at 15 degrees, we can see that it literally gets slanted. And the nice thing is that I can actually change this from one end of the wall to the other. So maybe that's negative 15. And, you know, that changes both of them, but that's just the way it is, which is cool. Then I have tapered. And so what is this telling us? Well, this is literally saying that I have to have a variable thickness built into my wall. And so where would we see that? Well, we would see that within a different wall type. Well, let's come over here. I'm going to copy this one over here so we can get an idea of what we're working with. And I want to make sure that I do have that. And you can find that in the structure. And we can see that I have all of these options, basically all these different layers within the wall that we'll get to in another video, but I can make any of these variable. So maybe in this case, I want the air, like the air barrier, not the air barrier, but the air layer to be a variable distance, which makes sense. And maybe you have more distance between the brick and the sheathing behind it in certain circumstances because the wall is angled. I don't know. We're going to use this as an example. Okay. And so with that, nothing changes because I didn't change anything. I just made it so that if some things happen, that the thickness of that air layer can change. And so let's go ahead and do this. I'm going to change this from vertical to tapered. And again, nothing's going to happen. And so what's going on here? Well, nothing happened except we have some more overrides. I see there's an override type properties. And so again, I can't change anything except these angles down here. I can change this here if I want to, but you'll have to see you end up creating an instance override. So let's go ahead and cancel this here. Obviously nothing happens, but I want to actually check that override there. And so immediately now I have access to it. So let's look at this. So basically this is kind of the same thing that we're working with as far as the angles, but we now have an exterior and an interior. So let's set this exterior to maybe 15, and we can see what happens. Like, look at that, 15 degrees. And then let's come over here to the interior, maybe set that to also 15 degrees. Well, this is kind of interesting. And so what is this? What's happening here? Well, we're going to end up cutting a section. I know we're doing a lot in this video, but I'm going to show you what we're looking at here. So let's go back to the floor plan. We can see that even without cutting a section, I don't even need to cut a section because the floor plan is, we can see that it's obviously kind of tapered and angled like a pyramid in this case, but I've got my brick, you know, I've got my section through my brick, and then I've got this giant white area. And so what is that? Well, that is actually our variable air layer. So the distance between here and there is, you know, it varies, which is kind of the point here. It now varies, but it is the air layer or whatever layer we set to be variable in our wall structure. In this case, it's the air, so the distance between the brick and the sheathing behind it changes based on the taper of the wall, which is really cool. So that's just, you know, again, something to be aware of. I don't necessarily know when or if I'm going to need to use this, but you can see that this is pretty powerful when it comes to making walls and making tapered walls. There's a lot that we can do here, and this is just in the instance properties of the wall. I could do this for all these walls at once. I can select them all and change all these different properties at one time, but I don't know. That's not something I want to do, but just know that you can do that. All right, so we've looked at literally everything except a couple other things here. Image, I never use that for a wall. You know, these are just default parameters that are built into walls within Revit. If you want to add an image, I don't know if you want to reference this type of wall with an image or something like that, you can do that. I don't know. It's something that you, again, whenever you schedule a wall, create a wall schedule, you can use that image in the schedule and blah blah. If you want to. Again, I've never done it. Never needed to do it. Comments, again, this is an instance parameter that you can add to this particular wall. If you want to make comments on this wall, it can show up in the schedule. You can also make new wall parameters that will show up here if you want. The mark is kind of interesting because that is, I mean, if you've ever made a door schedule, then you know how marks work with doors. It can work the exact same way with walls. I don't know why you'd want to do that, but if you have a system where you end up tagging walls based on a certain type or something like that, then you could absolutely have a mark for a wall, and you could schedule walls out that way, just like doors, kind of. Interesting. But then finally we have phasing. Because this is a model element, we have all the phasing options, and that applies everywhere. Any model element has these options. And the default, of course, is that it's in new construction. And it's not demolished. That's just self-explanatory. I have a complete separate phasing videos, so please watch that. It'll go through everything you might need to know. So we have looked through everything when it comes to the basic properties, the basic instance properties, instance parameters, everything for walls. And this is going to be the first video in a long wall series, and we're going to look at everything when it comes to walls, because clearly there's a lot here, and then clearly within the structure there's a lot here, and I'm not even going to expand this preview window. I'm just not. So there's a ton to do with walls, so obviously come back for more. If you did happen to learn something, which I sure hope you did, this was quite long, and we covered quite a little bit, but in great detail, and hopefully you know how to model walls a little bit better. So if you did happen to learn something, please demolish that like button. It really helps me out quite a lot, and thank you all who have. So at this point, I will say goodbye until the next time. See you in the next video. Have a wonderful day. Thank you for watching.